All right, so we are continuing with 2-6, and we are picking up where we left off yesterday. And in this example number 2, we are going to find slope instead of doing it like we did here, where we just counted the difference between one point to another. So if you don't use the formula, you literally just look at it and say, this is point number 1, this is point number 2, and then you look and see how much do you have to rise, right? You have to rise from 60 to 90. So your rise is 30. This is a very quick review over your run. Well, your run is how far. You always kind of make a box out of it, okay? You run from 2 to 3, which was a run of 1. That's your run. Run always goes left and right. Rise, we say rise, but actually it can be a fall as well, and I'll show you an example of that. So if you have a graph to look at, you can simply kind of make this box out of it and then say you rise. Say you rise. Seriously, there we go. It's rise over run, right? It's how far up do you go? How far over do you go to get from one point to another? That's how to do it by looking at the graph. Example 2 shows us how to do it if we maybe don't have a graph to look at, like our jump start. We didn't have a graph that we could count from one point to the next. We just simply had 2 points. So we have to use an equation. This is what I want you all to star, circle, highlight, square, whatever you need to do to make sure you can easily find this, because we will be coming back to this equation a lot. So everybody, please, in your notebooks, please mark this, notate it, put it as important, however you do it, because I want you to be able to find it a lot, because you're going to use this a lot this year, a lot next year. Slope stays with you for a better part of your high school math. Okay, so slope is rise over run, which we've already talked about. It's going from one point to the next. How far do you go up? How far do you go over? Okay, and if the line's running downhill, it's how far do you go down and how far do you go over. But I'll show you that here in a minute. When you do slope with the formula, and I also want to mention this, I had my kids look it up one year. You actually, the letter for slope is M. So you'll see M equals a lot. And I had my kids look it up one year. It's because there is some Latin word that means rate of change, which that's what slope is. It's the rate in which you go up and over, up and over. There's some Latin word for rate of change that starts with an M. I don't remember what the word is, but that's why we use M for slope. Doesn't really make sense unless you know Latin. All right, so if you have 2 points, you have to name them, okay? So now this one, I don't really know. They give you a graph, and so really you could just find it kind of the easy way. You could say, here's point 1, right? And point 1 is at this 400 level, and we want to fall, right? I say rise over run, but it can be fall. You want to fall until you're even with the other point. Well, how far did we fall? We fell from negative 400 down to negative 800. So that was a negative 400 drop. Okay, we fell from negative 400 to negative 800. That's a negative 400 drop. Then we look at our run, right? Our run is kind of doing the other part of the box, which is we go over. How far did we run? We ran from, I'm used to doing it down here, but it's actually up top. We run from 5 over to 10. Okay, so we go from 5 to 10. That is a +5 movement. So with the graph, just looking at it, we don't even have to know the coordinates or use the equation. We can just look at the graph and we can count how far did we fall, how far did we run to the right, right? We ran to the right, so that is a positive run. We ran down or we fell down, so that's a negative. And so that would be negative 400 over 5, which reduces to negative, what is it? 80. So the slope here would be negative 80. Okay. Now, the way they do it here is they take the coordinates, and so they actually write the red point as the point 5, negative 400. And then they write the blue point, which was Here's the blue point. It was 10, negative 800, right? And they call this one right here x1y or x2 y2, and they call this one x1 y1, okay? And then they plug it into the formula. So here is your, try to keep it color coded. Here is y2 minus y1, and notice it's minus a minus, so eventually, right, that will go plus. And then underneath, it is x2 minus x1, okay? And then when you do that or you reduce it, you get negative 400 over 5, which again reduces to negative 80. So if you're just given points, you have to use the formula. If you're given a graph, you have your choice. Do you want to count it on the graph, or do you want to name the points and use your equation? You can do it either way. You see, you get the exact same answer either way. Okay? That's how to find slope from 2 points. So this is just a quick practice of that. We're not going to spend a lot of time on this, okay? The red point is right here. So this is x1, y1. The blue point is here. This is x2 and y2. And again, you can do it one of 2 ways. First, you can look at your rise. That's your rise, right? Over your run, which is this. This is your run. And you can just count it. You can look and see that you rose from 110, right? And they tell you it's 110 right here. You rose from 110 up to 220. Well, if you rise from 110 up to 220, that is a rise of plus 110. Okay. Your run goes from 2 to 4, right? So your run goes from 2 to 4, or a plus 2. And so if you write that as a slope, it's your rise over your run. And when you reduce that, you get 55. Okay? Now, they do it over here with the points, and that's fine too. Okay? They took y2 minus y1, and they took x2 minus x1, and they got, right, they don't actually write this step, but they reduced it and got 110 over 2, and they reduced it and got 55. So you get the same answer either way you do it. Now it asks you to interpret it. Interpret the slope. What does it mean? This is going to change with every single problem because every graph tells its own story. This particular graph tells the story of distance traveled in miles over time in hours. So what this means, what 55 means, is that you go 55 miles, right, per what? Every, well, it's over 1, even though it's not, but it is, per 1 hour. Yes. Yes. Is that what you were going to ask too? No. Oh, yeah, you can. You don't even have to ask. Yeah, and if you want to, if the base is 1, you can write 55 miles per hour because that's kind of a common abbreviation that we use in the United States. So I'm fine with that, okay? But you really have to look at your graph and be careful because is your graph talking about dogs walked per month? Is it talking about sand, buckets of sand per day? Is it talking about tree growth over years? It just depends on what story your graph is telling. So you really have to look at how is your y-axis named and how is your x-axis named to be able to interpret a slope and say this particular slope means that this person moves 5 buckets of sand per hour, okay? Or whatever it might be. It just depends on how your graphs are labeled, okay? Sound good? All right. So this says try it. We'll do this really quickly. Okay, we can label these, right? If we want, we can label these x1 and y1, and we can label this x2 and y2. And if we do that, we would say y2 minus y1, or our rise and fall would be 70 minus 35 over our x2 minus our x1, so 50 minus 25. And we could reduce the top. 70 minus 35 is 35. And 50 minus 25 is 25. And then we always reduce a fraction if you can. So our final answer here would be 7 over 5. Okay? 7 over 5. That is known as the slope, also called the rate of change. Okay? Also called the constant of proportionality. Most of the time you'll hear it called slope or rate of change. Okay? Does it make sense that our slope is a positive 7 and a positive 5 and our line is going uphill? Yes, all positive slopes should be going uphill. Okay. The other way you could have done it was you could have done your rise. You could have kind of created a box here and you could have done your rise over your run. And then you could have figured out that your rise is from here to here and your run is from here to here. Okay. But it doesn't matter which way you do it. You're going to get the same answer either way. All right. Are we good with that? Okay. Go down. That's just the same thing. That's key concepts. That's just the same thing. Okay, we've done this. Now, if you are not given points, you have to find 2 good points. Do you guys remember what I said makes a good point? Right. Your blue line goes right over the intersection of 2 of your gray lines or your grid lines. So this point right here would be a great point. Okay. And if I was to name that point, it's the x value of 1 and the y value of 3. I'm a very visual person, so I usually will make those little dash marks. It just helps me mentally to name a point. Okay. Another good point, if you keep going up your line, here's another good point because it's right on your line and right on a grid pattern. And if I was going to name that point, that is x of 2, y of 6. Now, if I'm asked slope, again, you've got options. You can either look at, right, you can do your rise, which is your difference between red point and blue point. How much do we rise? We go from 3 up to 6. So what is our rise? 3. Okay. Over our run. Well, our run makes the corner and runs to the point. Notice I'm always making boxes. Okay. So I go up for my rise. I go over for my run. And for my run, I run from 1 to 2, which is a run of what? 1. And so I would reduce that to 3. Okay? We're good on that. How to do it with a graph, how to do it with points. Okay? All right. I want to show you a couple things that you'll need for your homework. Okay, this I think is pretty self-explanatory. I think we're good. I think we're good. Just remember that if you're going down, okay, first of all, got to fill in some blanks here because it doesn't tell me all the numbers I need. If this is 0 and this is 4, what would I name this one? 2. Okay, that's a 2. And then that would be a 6, right? And then go in the other direction. This would be a -2, but this one falls right in the middle, which would be a what? -3. So you really got to fill in some blanks here. Now, with those blanks filled in, right, here's what I'm going to do. I'm going to go from my red point, and I'm going to drop down. I'm going to make a box. Well, let's keep it. We've always done this in purple, so let me keep doing that in purple. So your rise, now I say rise over run, right? We say that all the time. That's kind of the generic way of saying it. But in this case, I don't actually rise, I fall. Because it's negative, I fall. But how much do I fall? I fall from 6 down to 2. So what did I fall? Not just 4, -4 because it's a fall. Then my run, I turn and I make the corner, right? I turn and I make the corner. and I run from -3 to, what's this one? -1. So what's my run? Is it negative? I went this way. I went to the right. Is that negative? Positive. Now notice, my rise was -4. My run was +2. If I reduce this, what do I get? Did I get a negative slope? Do I have a line going downhill? Does that check out? What if I had made the mistake, and this happens a lot, and this is why I'm pointing it out. Don't write this part down, just pay attention. What if I had written -4 over -2? When I simplified that, what would I have gotten? I'd have gotten +2. Can I have a positive slope with a downhill line? That's got to be a big red flag. Or if I forgot that I fell and I just wrote 4 over 2, right? I forgot that I fell and I wrote 4 over 2. That reduces to a +2. Can you have a +2 with a downhill line? No. Let that be your check. Let that be the way you catch a mistake, is you say, I cannot get a positive number for my slope if I'm physically looking at my line and it's running downhill. Something doesn't compute. Yes, compute. So if you're looking at it, you always read, let me erase all of my stuff here just so it's kind of a clear picture. Okay. If you're looking at this line, you always read lines left to right like you read words. So that means you start on this side and you read it left to right. And going left to right, we go downhill. Okay. If this was a positive line, it would look like this, because when you start reading it left to right, you go up. It increases left to right, or it decreases left to right. And that's how you know. This will always render a positive slope. This will always render a negative slope. Yes. Does the run always positive? Well, okay, that's a great question. And I'll show you. I love that. That is a perfect question. Let's take this for example. Okay, he asked, is the run always positive? So you guys saw that I did my box like this and then like this, right? What if I had done it like this and gotten a +4 and then run backwards to get to my point? That would have been a -2. When I set that up as a fraction, I get +4 or over -2. Does that still reduce to the -2 we needed? It does. So that's a great question. If you have a negative line, one of your moves will be negative. If you fall, you got to run positive. If you rise, which is positive, you got to run back negative. That's the only way to get a negative slope. Yes. On the original one? Okay, so you have to kind of fill in some blanks here. But if this is 0 and this is -4, that means this is -2, right? And if that's -2, then half of this is -1 and half of this is -3. So you really got to kind of get in there and fill in some blanks. And I went from this point, which touched at -3, over to this point, which touched at -1, and that's where I got the difference of 2. Does that help? Yeah. Good question. I love you guys. This is showing me that you are really like thinking over this, which is phenomenal. Yes. No. I see what you're saying. No. If you are doing a Math Excel and you are showing me your work and they give you a graph like this, you do not have to recreate the graph. Okay, all I want you to show me is that you rose. In this case, we rose 100. We ran 4. So this right here is the work I would see on your paper. I'm not going to see the graph in the grid. You do not have to take the time to recreate all of these graphs on your paper. Okay, good question. All right. Are we okay on finding slope from a graph? Finding slope from 2 points. Are we good with that? The main thing, if you're doing it with 2 points, name your points. Call one group X, call one group 1, call one group 2. Yes. Thank you. All right, so we're not quite done yet because I want to help you with 2 things that you're going to see on your homework, okay? One is a problem like this. So I want you to turn to page 132. Okay, page 132. All right. It says you use a garden hose to fill a wading pool. If the water rises 11 centimeters for every 5 minutes, you record the data point 10y. What is the value of y? Guys, listen up. You're going to have one just like this. First of all, you need to pull out some given information. They give you this 11 centimeters for every 5 minutes. So they give you one good proportion. And we can write that proportion as 11 over 5 because it's distance over time, right? So this is our given equation. That's a good equation they give us. Then they give us some half information here. They give us this right here, this half information. They tell us 10, but they tell us we need to find y. So we're going to take our good information, set it equal to our half information, and if we're missing one piece of it, can we find the other one? All right, based on what we learned Wednesday, does the 10 go on top or the y? The y. Y always goes on top. Time always goes on bottom. Remember that this was 11 centimeters over 5 minutes, right? So it's distance over time. Now we can solve for y, and we get 5 times y is 5y, and it's always one wing equals the other wing. So this is 110. Divide by 5 and divide by 5. And you get y equals 110 divided by 5 is 22. So what does that mean? 22 what? Yes. That's fine. That works. It's the same thing. Yep. She recognized you could multiply 5 times 10 or 5 times 2 to get 10. So 11 times 2 gives you 22. However way you work it out is good. 22 what? Centimeters per what? Not 1 minute. Per 10 minutes. You got to be careful. What if I wanted to know what the rate was per 1 minute? Yeah. If I want to know what it is per 1 minute, and you do have a couple questions like that on your homework where it wants to know per 1 minute, then you got to know your denominator has to be 1, and you divide by 5, and you divide by 5, and you get 2.2. Okay? If it asks you for the slope or for the rate of change, I'll tell you this on your homework, just leave it as a fraction. If they ask you what it is per 1 minute, you have to do this. So you've got to really read your questions carefully. And then the other thing we will talk about on Monday, it's how to choose which one of these graphs best fits these 2 points. And just remind me on Monday, and we'll talk about it on Monday. Sound good? All right. For those of you at home, make sure you take notes in your workbook or on paper, and then do the assignment online, and make sure you do all of your work on a separate sheet of paper and bring it back to school when you return.